Hi guys, so in this lecture we'll be seeing some of the exceptional rules um, pertaining to ambiguous acidic or basic strength. So let us start. Okay, so we have something like you need to compare the acidic strength between this is OH, this and this. So for comparing the acidic strength, so you must draw its conjugate. So in conjugate, every O will have a negative charge on it. So as a Cl group, the nearest the Cl group attaches itself to the relative to the OH or to the O minus group, more it will have its effect as a minus I. Okay, so in this the acid strength would be this. Second example is we would have what would be the acidic strength for so let's say these two groups are bulky, so it would have SIR effect which would lead to the rotation of this bond, and no plus M effect will be there from the phenyl ring to the carboxylic ring to the carboxylic acid. Hence it would favor the donation of or the deprotonation or donation of hydrogen ion from CO2 group. Okay, so this would be more stable. And now because of the minus I effect of Cl, the nearest the Cl attaches itself related to the CO2 position, CO2H position or CO2 minus position in the conjugate base, the more it would be the more it would be stable because of its minus I group. Okay, so this would be the order. Now let us look at into some example here where you need to comment or compare the acidic strengths of the following. This and this. So to compare the acidic strength, let us say that H is removed, so this compound would look similar like something like O negative, and this is OH. Similarly this is OH, and this would look like let me draw the complete structure, and this would look like okay. So now, as I mentioned earlier in some of the video lectures, that this will have a hydrogen bonding. Why? Because the O group attached to it will ensures that this hydrogen has delta positive on it, and there is excess electron on it, so it would form an hydrogen bond. Similarly, you can say for this and for this as well. So the extent of hydrogen bonding is more in this case, slightly less in this case, and no in this case. Rest all conditions are same in all the three compounds. Hence the acidic strength would be this. Okay. Now let us see some more cases. So we have CPM. This is called CPM or cyclopropyl methyl cation, where we need to comment on the stability of these two compounds. So obviously this is something like aryl, where you have a positive on a carbon atom in benzene, so this would be less stable. Let's comment on the stability of these two compounds. We have CS3 here, and you need to compare the stability between these two compounds. So that it is metaxylene it is paraxylene. So remember, I told you that the stability of metaxylene is more than stability of paraxylene, and I told you that it's a fact you should remember. Okay, let us comment on the stability on the acidic strength of this. So I hope you remember that this is more acidic than this because of the SIR effect. So plus m of the benzene ring will not be there, unlike in this case. So I'm just summarizing all the important examples which we just discussed in some previous lectures, so that I remind you of the same. It would be helpful for you to remember them in the future as well. That's why I'm discussing these examples twice. So what would be the basic order? This is stability. This is also stability. And so what would the order here? What is more basic? This is more basic. Why? Due to the steric hindrance, the incoming acid group is not able to attack it. Okay, so with this we come to the end of this chapter, and from the next video we'll be taking on isomerism as our new chapter. Okay, till then, good luck and goodbye. And also one more thing, keep revising your organic concepts because they fade out like anything in students' minds. Okay, so I request you guys to roll over those videos again and again so that you are good at remembering the important rules, important examples, exceptions. So it would be really useful for you in the future or as an exam perspective. Okay, bye bye.